Okay, so we have been looking at correlations in our data, and now we are going to create a line of best fit. So a line of best fit is a straight line that tries to match the trend in the scatter plot. So what we talked about, how we have positive, negative, and no correlation, we are making a line of best fit that can match that correlation that we found. A line of best fit is a straight line. It passes through as many points as possible with equal numbers above and below the line that are equal distance from the line. Okay, so what we want to do is we want to create a line that goes through the data. What we see is that we have a positive correlation here, so our line needs to be in the positive direction. And we can get most of the points to go through the line like so. So everything is touching the line of best fit here except one above and one below. Okay. And if we're looking at how many points are touching the line and how close those other points are to the line, we'll be able to identify whether we have a strong correlation, a weak correlation, or again, no correlation. So here we can say that we have a strong correlation because everything is either on the line of best fit or very close. Okay, looking at this next graph here, we want to create another line of best fit. Okay, so looking at the data, we see that we have a negative correlation, and creating that line, I can get the line of best fit to pass through 3 lines and have 2 above and below it. Here we can say that we have a weak correlation because not that many points are touching the line and they're a little bit more spaced out. Now with this one here, most of our points are up here in the positive correlation direction, and we only have this one point over here. So we're going to be talking about what an outlier is, and that's what this point is because it doesn't go with the trend of the data. So I'm going to ignore that point when I create my line of best fit. Okay, so most of the data is up here. It's just that one point at the bottom here that doesn't go with most of the data. Okay, and if we look at this one here, we see that we have different data points everywhere. There's not a positive or negative correlation, and that means that there is no correlation here. When there's no correlation, we can't make a line of best fit because we wouldn't know what direction to put it in. It won't follow any of the data. So we can just leave this one as is. Okay. And looking at this one here, we can notice that our data points are taking on a specific path, and that's a non-linear path. Okay, so since we have this, we can actually create a curve of best fit rather than a line of best fit. So I'll create a curve of best fit that can go through all of the data points because they're specifically lined up heading in a certain direction. Okay, so like I had said before, an outlier is a point that is far away from all the other points. If all points are in a straight line, then we say that the relationship is linear. If all the data points are close in a line, we call it a strong correlation. A weaker correlation shows the relationship is more spread out. Okay, so the data points, if they're close together, it's strong. If they're far apart, it's weak. And then we have our difference between a linear relationship and one where we are drawing a curve of best fit rather than a line of best fit. Okay, so that last one was showing that a curve of best fit would be better than a line of best fit because the points aren't linear, they were specifically headed in a curved direction. Okay. So why are we creating a line of best fit? So a line of best fit, it's to be able to estimate or predict values within the data set that we're given. So because it's not a specific linear graph, there are data points, it's a scatter plot, those points are everywhere. Not every point is going to be on that line. Then this is an estimate or predicting values rather than there being a very specific answer. If it was a linear graph, we would have a specific answer, but because it's a scatter plot, not everything is exact, we are making an estimate. So interpolation is if we are making an estimate that is within the data set. And extrapolation is predicting values that lie beyond the known values. So if we create a little scatter plot, and we have a line of best fit for that. And if we have a point within the data, okay, so this can be somewhere that lies within our data, meaning our data starts here and ends here. So anything that's in between lies within the data, and that's when you're using interpolation. Okay, and extrapolation is when it's outside of the data. So it would need to be, if the data is starting here, it needs to be the left of that, or the data ending here, it needs to be the right of that. So it could be a point over here because it's outside of the data set. We look at two things to decide if our predictions are reliable, how confident we are in the prediction. So the data spread. Data spread over a small interval is less reliable than a model based on data spread over a large interval. Trying to predict a trend from a cluster is difficult. Okay, so that could be saying if we collect something that happens on one day versus collecting the data over a bunch of days, over a month, over a year, that's what can make it more reliable. And the sample size. The more data we use, the more reliable the predictions. So if you're only doing a sample twice, then there's only 2 points. You could make a line on that, but it's not much to go on. If we tried something 50 or 60 times, that would make a strong case as to where the data is going to lie and if there is a correlation there. Okay, so looking at an example, the following table shows the mark of students before and the before an exam and the mark they received on the exam in a grade 12 math course. So the mark before the exam is the independent variable, and the mark on the exam is going to be the dependent variable. So we want to plot all of these points. So the first point is at 8480. Next is at 7372. Point at 7068. $95.93. $92.90. $61.58. $25.29. $65.60. $51.42. $73.73. Okay, so we kind of end up with 2 points on top of each other here. Let me make them a little bit smaller. And $62.57. Okay, so with these points, we notice that we have a strong positive correlation. And we can make a line of best fit. Try again there. Okay. And now we have a few questions on the following slide to answer. So use your line of best fit to predict a student's exam mark if they had a 78 going into the exam. So looking at this here, if they were starting at a 78, that's going to be around here. We can go up to our line of best fit to be able to predict. And we notice that it's going to be somewhere around the 75% mark. And a student's mark going into the exam if they got a 50 on the exam. So getting a 50 on the exam, that's starting here and going over to the line of best fit. And if we go down from there, that's going to be around 52 or 53%. Okay, as long as you're in the right range, this is an estimate, so we're not going to have a very specific answer, as long as you're in the range of what we're saying here. A prediction like this made inside is known. Okay, so because our data set goes from here to here, and we are using points within the data set, then that is interpolation. Okay. And a student's exam mark if they had 20% going into the exam. Okay, 20% going in. Go to our line of best fit, and we can go across, and this is around 14%. And a student's mark going into the exam if they got 100% on the exam. Okay, so starting over here at 100, we can go across to our line of best fit. And we will go down, and we get 100%. Okay. And a prediction like this made outside the known values is called, so like we said before, our data set starts here and ends here, and those yellow markings are outside of it, and this is called extrapolation. Okay, so make sure you're being as accurate as possible when doing the practice questions. Use a ruler for your line of best fit. And also there is an activity using Google Sheets on Google Classroom. You're going to complete that first, and then you're going to move on to textbook questions. And you're going to have tomorrow to work on this as well. Okay. If you have any questions, please let me know.